All right, class. So we're about to begin Module 3, Lesson 1, which is identifying functions. Now, before we go into our examples, we need to look at some key things and facts about what a function is and some definitions. So the first definition we have is a relation. A relation is a set of ordered pairs, and you know that every ordered pair has an x value and a y value. Now, these ordered pairs can be written in a list, as a table, or a graph. Okay, so they can give it to us in these three ways: a list, a table, or a graph. Now, in every ordered pair, we have what we call domains. Domains are the x values, the range is the y values. All right, say it again. The domains are the x values, the range is the y values. The next definition is independent variable. Independent variable is the same as the x values, okay? And the dependent is the same as the y values. So that's like your input and output. Your input for your x values, your output will be your y. Your independent is the x value, the dependent is your y values, okay? Now, the whole goal of this lesson is to identify functions. Now, in order for us to identify functions, you have to know that a function, you have to make sure as well that each x value is matched to only one y value. So that means each x value is matched to only one, okay, y value. To break that down a little bit more, the x values cannot repeat. So when we look at these lists, these tables, even when we look for an equation, we have to make sure either one of those that the x value cannot repeat. And if it does repeat, it's not a function. If it don't repeat, it is a function. Okay? Now, like I mentioned before, we can see we're going to be using equations as well. So equations for us are going to be called linear equations. And that a linear equation function is an equation that can be written in standard form, which is ax plus by equals c, or slope-intercept form, which is y equals mx plus b. Now, looking at these three examples that I have, these are in standard form and slope-intercept form. Now, the key thing about these is what you don't see is exponents. You don't see absolute value symbols. You don't see variables at the bottom of a fraction. You don't see any of that when it's dealing with something that is in standard form and slope-intercept form. So if it don't fit the standard of ax plus by equals c or y equals mx plus b, it is not a linear function. Okay? So now that we have some background about what we're about to go over is identifying the functions and to determine if the equation that we have is a linear function or not, let's look at some examples. All right, so for our first set of examples, it says we got to decide whether each relation is a function or not a function. If not, explain why you think it is not a function. So when we look at the first one in that, we have a list of ordered pairs. So we have 2, 5, 3, 7, 2, 8, 4, 1. Now, in order for us to determine if we have a function or not, we're only going to focus on the x values. Okay, so only the x values are the important part when identifying whether it's a function or not. So we're going to go through, we're going to highlight all the x values in this list on the order from the order pairs. Now, when we highlight all of them, what we're looking at to see if the x value repeat. If the x value repeat, it is not a function. If it don't repeat, it is a function. So the numbers we have for x values are 2, 3, 2, and 4. So now this one, if you notice that the 2's are both positive 2's, because of that, that means this is not a function. Because the 2 repeat. Okay? Now in the next list, we have, if we go through and highlight all of the x values, we got -1, 0, 1, and 2. And that what you notice is we have -1, 0, 1, and 2. Now, if you look at that, that's a -1 and that is a +1. Because they are opposite signs, that means they're not being repeated. So this one here would be a function because no x values repeat. Now, if we go to the third list, in this list, we got x values of -3, -2, -1, and 0. Now, just looking at what we highlighted, none of those numbers are repeating. They're all different numbers, so this one would be a function. And the last list, go ahead and highlight our x values. X values, if you don't know, is the first number in the order pair. Now, when we identify what our x values is in the list, we got 1, 2, 1, and 3. So if we notice, the 1 is being repeated, so this is not a function. Because 1 is repeating. Okay, so now we looked at how we can identify functions from a list. Let's move on to our next set. All right, so in our next set of examples, we're going to be looking at it as a table. So in a table, it's the same thing. We're looking to see if the x values repeat. So let's look at the first example of a table. It says which table represents a function. So for it to represent a function, we know that the x values cannot repeat. Okay, so when we go through and check all our x values, it cannot repeat. So the x values for answer choice A, if we look at this one, we notice that the 2 is repeating, even the 4 is repeating. So answer choice A cannot be it. And then if we go and look at answer choice B, we look at just the x values. So if we're looking at just the x values, that means nothing here is repeating because you have 2, 4, 6, and 8. Neither one of those numbers are being repeated in that column. So answer choice B could be the answer that we choose. Now if we look at answer choice C has nothing but 4s in the x column. That means there are 4s being repeated. So answer choice C definitely cannot be it because it has repeating numbers. And then in our last one, answer choice D, if you look at that, we have 4, 6, 8, and 6. The 6 is being repeated. Because the 6 is being repeated, that means it's not a function. So the only one that would be a function in this one will be answer choice B. Okay? Now, moving to the next one in the table section. This one says which one is not a function. So because we're looking for one that is not a function means the x value can repeat. All right, since it can repeat, we're looking to see a number that is doubled up only in the x column. Okay, so if we look at answer choice A, we have -3, -5, -14, -15. Nothing is repeating here. Okay, if we look at answer choice B, in answer choice B, we'll notice that we have 6, 10, 10, and 12. The 10 is being repeated in this one, so because the 10 is being repeated, that means it is not a function. So answer choice B could be our answer. But let's check the rest of them. Answer choice C, if we look at answer choice C, it says that we have -2, -4, -8, and -10. Nothing in that is being repeated. And then the last one, answer choice D, we have -10, -7, -6, and -2. Now with that being said, nothing is being repeated there. So that means the answer, the only one that will fit for not a function will be B. Alright, so now that we're finished the tables, let's look at the final section. Alright, so in this last section, we're going to be looking at how we can identify linear functions in equations. So in order to do that, we're going to focus on one question at a time. Like in this one, it says which represents a linear function. Now, in an equation, it must follow the standard form, which is ax plus by equals c, or it could be y equals mx plus b. So if we go through and break apart each one of these choices, we're looking for it to fit that standard, or standard form, or slope-intercept form. Okay, so if we look at answer choice A, what we notice is that in this question we have an x at the bottom of the fraction. That is something we cannot have. Okay, for it to be a linear function, we cannot have an x at the bottom of a fraction. Okay, answer choice B, what we notice is that we got an exponent of 2. This is something that we cannot have. We cannot have exponents for it to be a linear function. And then you have in answer choice C, you'll notice that we have these two, which are called absolute value signs. You cannot have that either. So neither one of these three options that we've been over, A, B, or C, you cannot have pieces of them equations in it for it to be a linear function. So because we cannot have it, that means it is not a linear function. The last one was answer choice D, but if you look at answer choice D, it says y equals 1/2 x plus 2, because it says that is actually slope-intercept form. So with slope-intercept form, that is a linear function because it graphs a straight line. So the answer for this example will be answer choice D. Now if we look at our last example, we're looking at it, it says which equation represents a linear function. So if we go through and we break apart each answer choice, we're going to pick out which one will fit ax plus by equals c, or y equals mx plus b. Okay, that is what a linear function equation should look like. So in answer choice A, it looks similar to that, but these parentheses on the outside, it tells me that this x can be distributed in. Because this x can be distributed in, that's going to give us really 3x squared plus 2x. And because of that, there's that exponent. We cannot have it. Alright, and answer choice B, we got y equals 2x plus 10. That looks like slope-intercept form. We're going to leave it there to make sure nothing else is considered to be linear. But if we look at answer choice C, we got an exponent again. That's something we cannot have. And then in answer choice D, there's another exponent. And you cannot have an exponent of 3 either. So the only one that fits the standard of a linear function will be answer choice B, because it is in slope-intercept form. Alright, so now that we have covered everything dealing with identifying functions, whether it's going to be looking at it as a list or a table, okay, or as an equation, well, we have to remember that if it's in a list or a table, that x values cannot repeat, and that if it's in an equation, that we're looking for it to be in standard form, which is ax plus b.